Alright, so we've gone over for loops, so we've gone over basically the components of how to write a program. That's what we've basically done for these first few weeks. And this is really the next, at least for 1068, this is the next intense part, which is arrays. And this chapter will cover a surprising amount of, let's say time, because let's see, it goes over string. So we'll go over arrays, and then it goes over strings a bit more, which we've already gone over arrays, and then we'll talk about objects and classes. In other words, how to make our own data types. But the first thing we need to do is actually work with like the most common data type, which is an array. We've seen. So in other words, we're finally going to learn what this means over here, the two brackets, which stands for this is an array. And it is very different than the list in Python. I mean, it's both very similar to a list in Python and also very different. So you may be surprised as to some things. So an array is essentially a group of things, right? When we were dealing with a single variable, like integer x, that holds a single integer, right? And if I wanted to hold another integer, I'd have to make another variable, right? So, and that was pretty convenient. But there's been a common problem that I always want to give, but then I have to remember, oh, right, you can't do that yet because you need to be able to handle collection stuff, and that's averaging, right? If I wanted to make a, say I wanted to take the average of a bunch of, write a program that basically made the average of a bunch of, let's see. Let's go ahead and say the average of a bunch of temperatures, right? So let's go ahead and go with weather average. Let's just go over here, make a new class, create it, call it public static void main, boom. Okay, so, right, and if I were to make this regular program and just basically to ask a user to enter a bunch of numbers and figure out the average, right? Right, scanner is equal to new scanner system.in, right? And the goal of this was system.out.println, enter how many days you want to record the temperature for. So we're going to record the temperature for a bunch of days, whatever the user says. Int numDays is equal to scanner.nextInt. Right, we're going to read in an int from the user, okay? The number of days. All right, so we want to read in the number of how many days does the user want to record the temperature for? System.out. So we can. Okay. And now what we can do is that basically, if we want to figure out the average temperature for a number of days, well, that's just simply the sum of all the temperatures throughout the day divided by the number of days, right? So we can do an int sum of temps, right, is equal to, let's see, sum of temps is equal to 0. And now what we would have to do is that we would have to simply write a loop. For int I is equal to 0, I is less than numDays.
How do you make that? What do you type in?
For I. It works in NetBeans as well. You type in for I, and it will try its best to autocomplete and then you hit tab, and it will try to auto-complete it for you. So 4i is equal to 1, I is less than or equal to, so I'm going to start equal to num days, right? Sout, enter day plus I, right? Enter day, you know, this day. And what we would do is that we'd say sum of temperatures plus equals the scanner.nextIn. We read in the next item from the user, right? Okay. So and then what we can do is that we can print out the number of days divided by the sum of the temperatures to get the sum of the temperatures divided by the number of days to get the average, right? So let's run this. That's what an average is. And it is how many days do you want the temperature for? Let's go with 5 days. So enter day 1. Let's just do, let's go with a very interesting week. 10, 20, 30, 40, 50. Very interesting week with very interesting temperatures, I'd have to say, right? And obviously the average temperature of 10, 20, 30, 40, 50, right? All those added together divided by 5 is 30, right? Because all those added together are 150. We divide them by 5, we have 30. So let's go with average temp. All right. I mean, and also we can track them. Now, one thing that we can do is that we can also track the minimum and the maximum temperature, right? The min temp is equal to, let's go with, yep, we started here. Actually, what we're going to do is that, int min temp, int max temp equal to 0. And here we actually run into a slight issue, because if your biggest temperature, if your highest temperature is like -3 degrees, right, which isn't uncommon if you're up north and it gets very, very cold, you know, and it's really deep in the winter, right, then the maximum temperature will end up being 0. So let me just show that, right? The way this typically works is, if we're tracking the minimum and maximum, is if the minimum temp, if the, so first thing I'm going to have to do is that I'll actually have to save this scanned value. Let's go with int this temp, or I'll just say int temp. Sum of temps is equal to plus equals temp. I can't do scanner.nextInt for the next one because that would tell me to read another another integer. So if the current temperature is less than the minimum temperature, then that's the new minimum temperature. Make sense? And if the current temperature is greater than the minimum temp, greater than the maximum temp, in other words, the biggest thing, if it's bigger than the biggest thing we've seen, then it is the new biggest thing we've seen. Make sense to everybody? Okay, and so now we can print out additional facts over here. You're missing a semicolon here. Sout highest plus max temp, sout lowest plus min temp. All right. So now if we run it, how many days do I want to record the temperature for? I want to record it for 5, 10, 20, 10, 11, 12, 13, 14, 15. So the average temperature was 12, the highest temperature was 14, and the lowest was 0. Well, the lowest was actually 10, but we had a bit of an issue. Our minimum temperature was 0, and none of our temperatures were lower than that. So what we'll do instead is that we'll basically, to make sure so that our lowest temperature will actually be red, what we're going to do is that we're going to set the starting value for minimum temp to be the biggest number possible. Now, then in normal mathematics, that doesn't make sense. You can't set something to the biggest number possible, right? Because there is no biggest number. But for integers, there is a maximum integer. So you get that by saying integer dot max value, and that'll be like a 2 billion and something. And we'll do the similar for minimum temp. We want the starting minimum temperature to be the smallest value, so that the first value we insert is going to be smaller than it. Make sense? And so now this will run just dandy, right? I want 5 days. First day is 10 degrees, 11, 12, 13, 14 degrees. The highest temperature was 14. The lowest temperature was 10. The average temperature was 12 degrees. Okay, obviously I'm working in Celsius here. Okay, so we can answer basic. So we can do averages, no problem. So now here's the frustrating question. Okay. Suppose I wanted to figure out how many days were higher than the average, were above average. There is really no way for us to do that, because in order to do that, we'd have to be able to save the values as we read them. Okay? We'd have to be able to save values as we read them. And here, we're just essentially throwing away the value at each step of the for loop. But if we want to know how many were above the maximum temperature, we'd need to know how many of them actually survive. How many of them are actually, we'd have to read them again after the for loop, right? They don't survive after the for loop, though, but we still need the values after the for loop. And, there's not really much I can do. I can't really make like a million int values, right, in the program and just write a for loop that goes through all of them. But what I can do is make something called an array. So we'll come back to this after we learn about our arrays for a bit. Yes?
So when you for point acceptance, the screen is also visible?
Yes, this is what's visible. Yes. Well, we don't have the previous values, right? We don't have the previous values stored. We can't reference them again. That's the issue, right? And I suppose that you could do something like save them to a file and then reread the file, but we don't want to get in. But that's just another way of doing what we're about to do, which is to create an array. So an array is a group of variables altogether. Now whereas x and y here are single variables, these arrays are going to be a group of variables. Like, consider like a filing cabinet, how you can open up a filing cabinet and there's multiple folders inside a filing cabinet. The array is that is that drawer, and each of the values are those folders. I'm going to reference this metaphor again because you can have multi-dimensional arrays, and honestly, it doesn't matter how big these things get. But they typically don't get bigger than 2, and they should not get bigger than 2. But there's nothing stopping you from making a 10-dimensional array, other than your own sanity. Which I would seriously question if you made one. So to make an array, there's 2 ways to do it. The first way is to declare an array like this. Int r, I use r for short for array. Int r, and I use that because I get to sound like a pirate then. Int r is, and this is how we make a literal array in Java. 1, so this will have the values 3, 5, 7, 2, 4. Okay? Actually, I'll go ahead and do 3, 50, -7, 2, and 4. Just that way there's no kind of values between them. Okay, so that's the first way you can create an array. Now you can only do this when you declare an array. So you can only do this like the first time an array is created, and once the first time you create a variable. You can't like say, I can't later go array is equal to 3, 4, 2. I can't make another array like that. It says that array initializer is not allowed here. You're only allowed to do it the first time you make an array. So this is the first way to make an array, but it's also the easiest. So what this does is that this creates a little box, basically where a variable would create a single box, right, to put a variable in. This creates in your memory somewhere a entire group. Okay? This is why, and now I'll be able to tell what it, when I switch. That way I'm not going to lose it. So 1, 2. Okay, so we had 3, 50, -7, 2, and 4. And you might realize this looks a little like the way that we've been dealing with strings, because it's exactly the way we've been dealing with strings. Arrays have values that are indexed, just like strings do. So 3 is located at index 0, 50 is located at index 1, -7 is at index 2, 2 is at index 3, and 4 is at index 4. Okay. So we have all these values. So we have these values stored in an array. Okay, and then we can actually use them fairly easily. We can reference them pretty easily. So I can print out array, and then this is array index 0, and this will print out 3. See, it prints out 3. If I say array at index 2, it will print out -7 because this is index 0, index 1, index 2, index 3, index 4. So we start at 0, -7. All right. A big thing about this array is that you can't change its size. You can change the contents of the array, though, but you can't change its size. So let's go ahead and show that we can change the contents of the array, right? So there's essentially 2 operations that you use in an array a lot of times. The get operation, where you get a value out, and this is what we did. Array index 2, right? I can also say x is equal to array index 3, so I can take a value out and store it in a variable like that. System outline.print x. So we're going to print out -7, and then we're going to print out 2, because that's what array, right? Because we took the 2 from over here, stored it in x, copied it over to x, and printed it out. Okay. Now you can change the contents by basically doing the reverse. We can say that y is equal to 1,000, right? And I can say array of index 4 is equal to, let's say, -56. And array at index 3, that's equal to y. So I can use anything that's an integer, I can put over here, right? Even if it's a function call. System.println. Let's see. So array 4. And notice that I'm printing out the individual elements. We'll get to the how do you print out the whole array thing, because that actually ends up opening a bit of a can of worms. So, right, I stored 56 in array 4. I printed it out. We got -56. And I stored y, which was 1,000, inside array index 3. So when I asked to print out what was in array index 3, it gave me 1,000. Okay? So these act as basically a group of variables together. Okay? Now you cannot change its size. The last index of this is 4. So if I try to go and add another element by saying something like array index 5 is equal to 6, right? Notice I have 0, 1, 2, 3, 4, but 5 is an empty space. If I try to say index 5 is equal to 6,000 or something, it'll run, and then notice that it compiles, but then I get while it's running, I get what's called an array out of bounds exception, right? Array out of bounds exception 5, meaning in other words, 5 was out of bounds. Okay, so if you try to go out of bounds, right? Right, this has 5 elements. If you try to go to array if you try to go to index array size or more, the array size or array length being 5, if you try to go above the length of the array, then you're out of bounds. So 5, 6, 1200, it'll be like that. And why is that? It's because these things are basically, once you create them in memory, they're a chunk of cohesive memory, and it all needs to be cohesive, right? All right. So you can't change the array size. Now you might say, some of you might know what an array list is, right? Especially some people in the back, right? I've seen you use array list a bunch of times, right? And array lists, they automatically resize, but actually those and they act like arrays. Well, really, what happens with array lists is essentially they just do there's no magic way to resize arrays. What they do is that they resize an array. You would actually have to resize an array, which is that you create a new array that's bigger and move everything over, right? So there's no way. The only way to change the size of an array is to create a new array and then copy all the stuff you want over. Okay. So all right. So I think I'll go ahead and cover iterating and printing first. So let's go ahead and create a new array. So let's go ahead the other way to create a new array, which is to give it which is to create an array like this. Int, so the type that you want, let's do an array of strings this time. You can make an array of anything just by adding the brackets like that. So this is an array of strings. In other words, it's a bunch of strings together. I'll call it words, right? Is equal to, and this is how we make a new array group. New string, and then notice over here I don't have parentheses. I still have the brackets. Basically, in here I'll put in how big I want the array to be. All right, I want it to be, let's say, 7 strings, right? So now I can put 7 strings in here. So up here, when we do main public static void main string args, this is an array of strings called args. Main actually takes in a parameter, which you can call it using the command line. So string words is equal to a new string. Now this is a bunch of empty spaces, which I'll go into right now. But right now it's just created basically a block of memory with 7 empty slots for strings. Okay. So let's start populating it. Words is equal to A. So words, right? I can't set a single thing to A, right? I have to set a single thing inside of. I can't set the array to A. I have to set something inside of it to A. So let's just go with A, B. Yep. And this is going to get immensely boring for just a second, but let's go ahead and see. So that's one more, and then insert. B, C, D. There we go.
How do you change your cursor like that?
That was the insert key, the much maligned insert key. That changes it to that changes basically, on keyboards, it's typically like paired with another key, like the delete key on my keyboard. That changes it into overwrite mode, which is very frustrating to use. But if you know what you're doing, it can be useful. So here I've got a bunch of words. So we can iterate through an array using a for loop pretty easily. So for int I is equal to 0. So I in this case is going to refer to the index. I is less than words. So the length of it is 7, right? There's 7 of them. So the indices are 0 through 6, right? There's 7 slots. So there's 0 through 6 of it. So the indices are 0 through 6. So we'd like I's range to be 0 through 6. I++. So this will go through 0 through 6 inclusively, right? 0 up to but not including 7. So system.println words I. So this is important to understand. This gets index I, which is 0, then index I, which is 1, then index I, which is 2, then index I, which is 3. So now when I run this, it will print out A, B, C, D, E, F, G, right? And now if I wanted to change it, just to show that I can change it, I can also go words I. The ith word is equal to, let's say, I, or let's say what's already in there plus the index that it's at. So now it should be A0, B1, C2, D3, E4, F5, G6, right? Now, typically, you don't know how big an array is, right? You might get passed an array as a parameter, which will show you how to do that. Typically, instead of just hard-coding the value of an array, because as you can imagine, if I change this to 8 and add another line in there, I want to make sure that that gets changed as well, right? It would be annoying to have to remember to change all the 7s to 8s, and I might accidentally change a 7 that doesn't need to be changed. So instead, over in these loops, what we'll do is then instead of trying to remember what the length of all the arrays are, we'll use the dot length parameter, the dot length variable that's part of all arrays. All arrays have a dot length, no parentheses. Now remember, so this is this is one of my many nitpicky things about Java. So to figure out how big something is in Python, you just have a len function, L-E-N, and then you throw inside what you want to figure out how big it is. Arrays have, if you want to figure out how many elements an array has, that's what these are called, elements. An array stores a bunch of elements. If you want to figure out how many elements an array has, you use words.length. If you want to know how many characters a string has, you use string.length, but the dot length has a pair of parentheses. And just to make things more confusing, when we deal with collections like array lists or linked lists or other stuff in Java, you have a dot size with parentheses because that makes sense. But anyway, but for arrays we're going to be using dot length, and it's a pretty easy fix if right, you're like, oh, I have parentheses here. Oh, I forgot to have parentheses here. Oh, actually, it's size, not length. Oops. It's a pretty easy fix. All right, so we use words.length, so this will go from 0, and this will be 7. Okay. Now, you might be wondering, okay, so why can't I just print out an array like this? Like, I've got the variable name. Why not? I'm going to print it out. To which I say, good luck with that, because this is your output. Okay, maybe that's just because it's an array of strings. Let's print out our original array, R. That's actually easier for me to parse, even though it looks like even more gibberish. It says, open bracket I at 38082D64. Okay, so what the heck am I looking at here? Well, this bracket I indicates that this is an array of integers, and it's located at memory location 38082D64 on my computer. Okay, that's where it's located at. This is an array of strings over here. It's located at DF-D3-711. So when you try to print it prints out the memory location of the of the array. Okay. So using a for loop is often the best way to do it. Actually, tell a lie. There's a bunch of stuff that are common operations that we want to do with an array. And they're located in just like there's an integer class for all the stuff you want to do with an integer, and a double class for all the stuff you want to do with a double. There's an arrays class for all the stuff that you need to want to do with arrays. So it's arrays plural in java.util, and you do have to import it. java.util.arrays. So you import that, and now we can use something called arrays.toString, which takes in an array as an argument. So let's pass it words, and it prints out our array. So arrays.toString will do that. If I switch this to R, and you can throw it at any array and it will do that. So arrays.toString will return. So what arrays.toString won't print out the array itself. What it does, it returns a string representation of the array. Right? It converts your array into a string. All right. All right. So surely though there's an easier way to go through my array though than a for loop, right? And the answer is actually yes. The easier way to go through your for loop is another for loop called the for each loop. So for those of you who are taking Python, this will look actually a bit familiar once I explain what the heck's going on. So this is a for each loop. So so notice that when I typed for, my IDE has a suggestion, create a for each loop. Now a for each loop looks like a for loop, only it doesn't have any semicolons. It has one colon in it. Okay, so, and this should be fairly easy to read. String word, colon, words. So this will look like the easiest for loop. This looks like the most simple for loop ever. Now we haven't used this before because really you can only use it on integers. I'm sorry, not integers, on arrays. We can't like use it over like other stuff. So how do we read this? Well, we read this as for each word, string word, and then this colon we read as in. So for each of this inside this collection of words. So you can do this over anything that's a collection, right? So a words, right, is our words is a collection of strings. So for each word inside of our words, does that make sense to everybody? For each word inside of words. Now notice what it doesn't give you. It doesn't give you the index. So if you want to change what's inside of an array, you can't do that with the for each loop. If you just want to print out the values though, or look at the values, the for each loop is the way to go. But the for each loop, you can't really change anything inside of an array using the for each loop. If you need to change stuff inside of an array, you have to use your standard for loop, using for int I is equal to 0, I is less than array.length. And we'll do examples with both the for each loop and the other loop. So the for each loop you don't have to use, but it's very useful. So let's go ahead and write a method. Let's go now take what we learned and go back to our weather average, right? So we've got number of days, okay? And actually what I'm going to do is I'm going to go and make this more Java-like. So string number of days, and I'm going to capitalize it and say final int number of days. Any idea what that final command does?
When we're running through code, the final will always have an if.
Good guess, but no. Completely wrong. Completely wrong, but a good guess.
You can't change the value.
That's exactly what it means. Final means you can't change the value. So it's very common for finals to be all caps. This typically is when we get values like pi. So say I wanted to create notice here that I've got, like here, if I were to use the math.pi, right, which stores the value 3.1415, right, I can't change it to 4. it would be terrible if I could, right? But here's the error I get trying to change math.py. I can't assign a value to this final variable pi. Once it gets a value, it's done, right? Once you declare what a final value is, it's done. So you can make things final and make them unchangeable, which is kind of useful. So, and what's the use? Well, so that you don't accidentally change it. You don't accidentally change it. Okay. So final int number of days. So we get the number of days. So we have sum of temps. Right? And now since we know how many days we are, what we can do to record all our days is that we can create an integer array called temps. It's equal to a new int. How big does it have to be? Well, we want one for each number of days, so it needs to be num days big, right? Makes sense to everybody? So now in here, what we'll do instead is that we'll go 0 less than temps dot length. So we're changing this up. Enter day, and we'll say I, and we'll just do 0 because we're going to start from 0. Arrays start at 0. That's just the way it works. And there's a number of arguments on the internet and memes about this on the internet, but arrays start at 0. So we get this. We've taken the temperature, but rather than storing it inside of int temp, what we're going to do is that we're going to store it in the ith value of temps, right? We're going to store that inside the ith value of temps. And then we're going to add that value to our sum of temps. If the value there, so notice I'm just adding s bracket I close bracket to this. So, right, what have I changed? I've said now we're going to enter the day. We're going to read in that value, and we're going to store it in first the first one in the 0th element. Then they're going to take the next one and sort in index 1. Then the next one in index 2, and so on and so forth. Right? So now I can easily run this program for how many days I want to record the temperature for. I want 10 days. 11, 12, 13, 14, 15, 16, 17, 56, 2, 20. Right? The highest temperature was the average temperature was 17, the highest was 56, the lowest was 2. Okay? But now we can also figure out how many of these were bigger than the average and how many of these were smaller than the average. Let's just focus on finding out how many are bigger than the average because we have all the temperatures stored now. Right? We know that this is the average temperature over here. Let's go ahead and store this in another variable. Int average is equal to that. So now we'll print out average. And now for int I is equal to 0. I is less than array. Sorry, it was called temps dot length. So this will be so if temps had 7 values, this will be all the indices from 0 to 6. Right? This will be 0 through 6. Right? Temps dot length would be 7, and so this would go over all the values 0 through 6, which is 7 different values. Let's also make a int num greater than average equals 0. So we're going to go through each of the temperatures, and we'll get the temperature. Int temp is equal to temps. So we'll get the ith value of temp. If temp is greater than the average, then num greater than average plus, right? So if this is greater than the average temperature, greater than or equal to the average temperature, we'll say the number that's greater than the average temperature. And now at the end, print out num greater than average plus days greater than average. So now, right, if I run this, enter how many days I want to record the temperature for. I'd like 10 days. 1, 5, 3, 6, 2, 2, 1, 7, 6, 5. So the average temperature was 3 degrees. The highest temperature was 7. The lowest temperature was 1. And 6 days were greater than well, or equal to the average temperature. And we were only able to figure out because we were able to do another loop with this. All right. So, sorry? Yeah, it was in doing integer division. I didn't bother doing floating point division because I was just making it simple and just dealing with ints. All right. So let's go ahead and write another function. Let's see how we can use an array inside of a method. Okay. So let's go ahead and actually just write we'll redo what we just did for simplicity's sake. We'll do a public static void, not void, but double here as opposed to integer, average, which will take in an array of integers. Okay? And we'll call it nums. So this takes in an array of integers, and it's going to calculate the average. Now we don't know how big. Now we don't need to pass in like how big the integer is. How big the integer array is, because we can use .length to figure it out. But let's see how we can do this. And remember, the average is the sum of all the numbers divided by how many there are. So int sum is equal to 0, right? We need to figure out the sum of all the numbers. And then the average is the sum of all the numbers divided by, which we haven't figured out yet, divided by the numbers dot length. So why don't we make this a different function too? Dot length. But to make sure we're returning a double, we'll say this is double sum. There we go. So we'll go ahead and write a function called public static substatic int sum, which given an array of integers called numbers, it's going to return the sum. Int sum is equal to 0, because that sounds like it's something useful to write. Return sum. So how do we write this? Well, we have to go through each of the values and add it to the sum. So int I is equal to 0, I is less than nums.length, right? So if there's 10 values there, nums will be 10, which means the indices are 0 through 9. Everybody following that? So double? Why did I say double static? Public static. Okay. Sum plus, so here we'll say sum is equal to sum plus nums, the ith number. So what's at index 0? Then what's in index 1? Then at 2? Then at 3? So now we can use this over here to say return. Actually, we can do this now in one statement. So the average is equal to sum, the function sum of the numbers, times 1.0. Why times 1.0? So that I can turn it into a double. And then divide it by the length. So now how does this work down here? How do I call it? Well, let's go ahead and make a variable called int array. What let's go with int let's go with int nums, or int sum numbers is equal to 72514. Sout sum of some numbers, and then sout average of some numbers. So their sum is 19, 7 plus 2, which is 9, plus 514, which is 10. So 9 plus 10 is 19. And their average is 3.8. Right, so it just passes the integers over here. All right, so it is 7:12, almost 7:15. So I think that what we'll want to do is that I'm sure some of you are still working on the previous homework. Yes, do some of you still have a backlog of homework? Yeah. So what I'm going to do is that I'll start putting up the array assignments. Now, what I'll do is that these I won't expect you to start working on, but if you want to get started working on them, you can. And I'll go over a couple of them with you in class when we start class. And then because I still have more to teach about arrays, but I want you guys to get the chance to actually work on stuff today. So really what it comes down to for the rest of the semester is that we're working with arrays, then we're working with files, then we're going to learn how to make objects, and then we're going to learn about object-oriented programming principles. And that's actually all we'll probably have time for. So, which is good because that's all we normally do in a semester.
Will we also learn how